This recording is for Statistics 1, Math 1 to 2, Unit 2, Assignment 2, number 6. It says 3 letters are selected at random from the word choose. So that's supposed to be 3. How many selections are there in all? How many of these selections contain only one O? How many of these selections do not contain the letter O? How many of these selections contain both the letters O? And as you can see, these the set of letters, they are repeated letters, there are 2 O's. So we have to take that into consideration. So let us draft an example very similar to this question. So the word that we have selected there is inserts. Okay. And insert has 2 S's. Okay, and it's very similar to the word choose. So that's quite a good choice. So how many selections are there in all? Okay, now we have to bear in mind when we're applying the combinations, calculated the combinations formula, the selections have to be taken from a set whereby all the elements are distinct. So we have to take that into consideration. So let us see how we are going to do that. As you can see, we have highlighted the fact that in probability analysis, the word and is translated to the operation times, and the word or is translated to the operation plus. So when we are doing our analysis, if we ever mention the word and, then that's a times. And whenever we mention the word or, that's a plus. And is plus in arithmetic. Okay, 5 and 5 is 10. Yes, 5 plus 5 is 10. But when you're using and in probability analysis, okay, we have to be very careful. We have to translate this to the multiplication sign, and it's or, the word or, that is plus. Now we have 2 S's. Okay, so what we have to do now is to create a set because we want to select 3 letters. Okay, so let's create a set whereby in that set there are distinct letters only. So you have I, N, 1 S, E, R, and a T. So we don't put the other S. Okay, so from that now, we are going, or N now will be, or small n, because we are going to use the NCR calculator. 1, 2, 3, 4, 5, 6, or any 6. And our R now is equal to 3. So that will give us the total number of combinations where all the letters are distinct. Okay, for example, INS, SER, etc. Okay, so that's clearly an N, that's clearly a 6, 6C3. Okay. However, it is possible for there to be 3-letter combinations with exactly 2 S's. Okay. So let's analyze how this can be made. So 2 S's, we fix the 2 S's, and we only have 1 more space remaining so that we can complete our 3-letter selection. Now from that set now, since we have fixed the 2 S's, we have to remove an S, okay, from the other S from the set. So now N is actually 5. Okay, an example will be SSI, SSN, okay, SSR, and so forth. So basically, we only want 1 now to complete our 3-letter combination. So we are randomly selecting 1 from 5. So that's 5C1, and that will give us all the combinations with exactly 2 S's. So now we can do 6C3 because we are selecting 3 from a set of 6 distinct objects. Okay, bear that in mind. In order for you to apply NCR, the set that you are selecting from must not have repeated letters, neither numbers. There must not be any repetition. So so we are doing a 6C3. 6C3 is 20. So that will give us 20 three-letter combinations where all the letters are distinct. Okay, what about all the combination of letters that have exactly two S's? You see, in that 20, there are some with an S and there are some with not an S. SER, for example, or ERT. But what about those with two S's? So that's why you fix the two S's, and we are going to only select one, okay, from 5 randomly. So that's a 5C1. Okay, exactly 5C1, as we know, obviously, 5C1 will give us 5. Okay, so our answer now will be all the three-letter combinations, okay, where all the letters are distinct. And so that and I'm saying then though is a plus because I'm adding, okay, I'm including, I'm doing a little bit of arithmetic. All those are exactly two S's, and that will be 25. Part B says, how many of these combinations contain only one? Okay, so the repeated word there is S. So let's just edit that to S. How many of these combinations have only one S? Okay, so for this now, what we've got to do, we've got to fix the S's. Okay, so for part B now, we've got to remove both S's and fix one. All right, and we are basically having a set of 5 distinct letters, and we need 2 from that 5. So that's a 5C2. It's okay to do the fixing because yes, you are randomly selecting, but it is possible for you not to select 2 S's. It's possible for you to select 1 S. So it's like a pretense whereby an S is not there. Okay. So bear in mind, we are calculating how many of them are present with only 1 S. Okay. So in your random selection, even though all the letters are present, it is possible to repeatedly select all those with 1 S alone. Okay. And that will be coincidentally whereby you are not selecting the other S. It's like as if it is not there. So it's okay to remove it from the set and create a set with distinct objects, distinct letters, INERT, and that's 5, and you're selecting 2 to complete your 3-letter combinations. Okay, so that's a 5C2. And that will give us 10. The third restriction, how many of these combinations do not contain the letter S? Okay, so therefore now, what you're actually doing, remember we said in that 20, there are those without any S's. For example, ERT. Okay, sometimes it's good to create an example of what you are analyzing just to get a feel of it. Okay, so remove the both S's, pretend that they are not there. Okay, because it's possible not to select them in your random selection. It's like as if they were not there at all. Okay, so deliberately removing them from the set does not affect your analysis of how many of them are there. Okay, so right now you've got a set of 5 distinct letters, and you need 3 from that 5. You are randomly selecting 3 from that 5. For example, ERT, TNI, example. Okay, so it's 5C3. And let's see how much this gives us. 5C3. 5C3 is also 10. But this is how many of these combinations contain both the letter, both the S's, both the two S's. Okay, we have done that already. Okay, contain the two S's, and here they are, because we have to calculate it first to get the total number, okay, in all, which is 25. There are 5 of them with exactly 2 S's. Okay, so we have done that already in the completion of part A, and here it is. We have fixed the both S's, remove them from the set, and we are randomly selecting 1 from the set of 5. Okay, just bear in mind, when you're applying NCR, the set that you are selecting on from must have distinct letters or distinct numbers. Each object, each element in the set that you are selecting on from must be distinct. And to do that, feel free comfortable removing or extracting the letters that are repeated, and sometimes remove all of them so that you can get them in your repeated letter combination, or okay, or not present at all, depending on what you are analyzing.